Hello, ninth graders. So we are today just going to take a step back and enjoy the fact that we now know all different ways to prove that triangles are congruent. We've got a few other things kind of at our fingertips to be able to prove and explore more into this idea of logical reasoning and proofs. So proofs get a lot harder than this. And we're only going to go so far, but I did want to show you kind of like what the next level is. We've been kind of gearing you up towards just proving that triangles are equal, and now we're going to start looking at proofs where proving that that triangles are congruent or triangles are equal is like one small mini step before we go and prove other things that are going on in the diagram. So what we were doing before is now just one step of many that we have to take in order to prove our final step. Let's ignore that thought, and maybe I'll come back to it later. But let's just go ahead and get started with this proof. We are given that angles 1 and 2 are equal, and 3 and 4 are equal. Before I even look at my diagram, I'm already here writing. So I'm just going to be like, okay, I'll just write out those guys right away. When we start to get to this level of proofs, when we have so many different things that we're going to be doing in order to get to our final piece, we've got like these little mini quests that we're solving before we get to the end. I like to start approaching my proofs from my given and from my proof. So I kind of start at the top down thinking of like, okay, well, I'm given this information and this information is leading somewhere. So I've got like these little like doors that I could go through with that information and start proving things together, using them together. So using all those pieces, they're going to start guiding you towards like these different avenues of thought, but they might not right away connect to what you're trying to prove. So then sometimes I like to go and then take a step back, don't write it on my proof, but just think about what am I getting to and how do I get to what I need to prove? And so sometimes it might be like, oh, well, I know that in order to prove this, I need to prove this first. So then you're thinking about this like bottom up approach to your reasoning of like, okay, this is where I need to end. Well, what are some things I have to say before I can end there? So we're going to start thinking about that a lot when we start to approach these proofs. So we're given that angles 1 and 2 are equal, and I've written it in my proof. So I'll go ahead and mark it in my diagram. And then we're also given that 3 and 4 are equal. Right away, I can see, okay, well, I can prove EBC is an isosceles triangle. I don't know if that'll be helpful, but I do know that it's an isosceles triangle, which means I can prove that BE and EC are equal. So that's a thought. And then I also have that 1 and 2 are equal, 3 and 4 are equal, which means that those whole angles I could eventually prove are equal as well. I haven't proven it yet. I do have to take a series of steps to prove that then those big angles are equal, but I could also prove that those big angles are equal. So I kind of a few thoughts in my head right now going along, thinking, okay, well, I could either prove the big angle B or big triangle BCD, and ABC are equal, or maybe I want to prove that AEB and DEC are equal. I don't know. I could prove either. I see some ideas that I have formulating in my head. But before I do that, I am going to look at what I want to prove. Well, I want to prove that AC and BD are equal. So that means I'm probably going to prove that the whole big triangles are equal, ABC and BCD. So I'm going to take a second to draw out those triangles separately, or if you're somebody who has like highlighters at home and you want to highlight the two triangles separately. But I've got A, B, C, and B, C, D here. Now I'm given that angle 2 and angle 1 are equal, and realize that this guy is angle 2 and this guy is angle 1. Going into your diagram, you can see that, and you've already got that those guys are equal. So between those two triangles, I have that those guys are equal. right? And then using the fact that my proof statement is a corresponding part between these two big triangles, I know I want to prove these two big triangles are equal, so I need to start proving some other pieces about them. We talked already about the angles, like making sure that those big angles are set up to be equal to each other. I don't know how I deleted that, but there we go. So let's talk about how to do that. I want to talk about the whole big angle B. Unfortunately, I can't just call it B, right? Because we're talking about there's 3 different angles there. So I'm going to call it angle ABC. I want to talk about angle ABC because I want to prove that it's equal to angle DCB. Yeah, DCB. But I want to talk about it, but I have to use things that I already know about it in order to talk about it. So I'm going to talk about angles 1 and 3. I'm going to say, okay, well, angle ABC is equal to angle 1 plus angle 3. Having 2 smaller angles adding up to a larger, bigger angle that it makes up, right, is called angle addition. I'm going to do the same thing with angle DCB. It doesn't rely upon anything else to be true. I can set that up whenever, so I'm going to just do it in the same step. Equals angle 2 plus angle 4, and it's angle addition, no need for a new reason. But I have set up that those guys are made up of each other. Now we know in our head, well, 1 and 2 are the same. 3 and 4 are the same. They have the same measure, but I need to show algebraically through their labels that the adding of them up together is the same. So how I'm going to do that is I'm going to take one of the equations, either one, and substitute in what it's interchangeable with, right? I want to make ABC look like it's 2 plus 4 instead of 1 plus 3. And I can do that because I've already set up the fact that I know that angle 1 and angle 2 are interchangeable. So I'm going to say angle 2 instead. I know that angle 3 and angle 4 are interchangeable, so I'm going to say angle 4. I've just taken out small pieces of one equation and plugged in other small pieces in there. That is substitution. Now we can say, hey, don't you notice that DCB is 2 plus 4 and ABC is 2 plus 4? Since they both look algebraically, symbolically like they are the same, now we can say they are interchangeable. So I'm going to write down next angle ABC equals, and instead of 2 plus 4, I'm taking out that entire half of the equation and writing in angle DCB. That is your transitive property of equality. Hey, I've just proven that 2 angles are equal. I'm going to go into my diagram. I like my separated triangles more, and I'm going to indicate that they are proven to be equal. Okay, well, I've got a lot about angles, which is nice, but I need some sort of side length between these 2 triangles to prove that they are equal. I always need at least one. And the relationship that these 2 triangles have, BC, is overlapping, and it's for both of the triangles. So thankfully, we know that that is then BC equals BC because of the reflexive property. If you are literally saying something is equal to itself, that is the reflexive property. Going over here and marking it down. We now have between those 2 triangles that they are equal because of angle side angle. Triangle ABC is congruent or equal to, doesn't matter, it's the same thing. Triangle DCB because of angle side angle. normally this is where we're like, oh, we did it. Okay, yeah, we have proven that these guys are equal. We're done. Now, this is just one small part of this proof. Now we have to see, okay, well, what are we trying to get to? We've proven that these two triangles are equal. That's great. Once we can do that, we have CPCTC available to us with all the different doors that it leads out of this room. So now we want to prove that AC is congruent to BD. And thankfully, that's just right away one whole piece and one whole piece of the triangle. This is probably about as easy as this proof is going to, as proofs on this are going to get. So now, what was it? AC and DB, but that's okay. Corresponding parts of congruent triangles are congruent. QED. Remember that your very, very final statement here needs to be the exact same as your prove statement above. These guys need to be the exact same, just like your first statement needs to be your given. Next proof. Exciting. Okay, we're given that angles 1 and 2 are equal. 1 and 2 are equal. 3 and 4 are equal. And then we're given that AB and AC are equal. First, we want to prove that ABD and ACD are equal to each other. So this is kind of like guiding you towards how you're going to solve this. And taking a look at this, again, we can see, okay, well, we already have AB and AC. So we've got corresponding sides. Maybe you're seeing that we can add up the angles and prove that whole big angle for ACD and ABD, right? That those big angles at A will be equal to each other. We have to do a little bit of manipulation, but we can totally do that. It's like what we did above. And then hopefully you guys can also see that we can prove that AD is equal to AD because of reflexive property. So it looks like we're going to have a case of side angle side here. And now I've got enough going on in my brain. I don't want to forget about any of this. So I'm going to just start putting it down on the page. Given angle 1 equals angle 2, angle 3 equals angle 4, and AB equals AC. Okay, I remember reflexive property was something I had thought about, so I'm going to just get that done right away. AD equals AD. I hope you're realizing by now that there's so many different ways and so many different orders that we can do this. So if you chose to do the angle addition first, then awesome, go ahead and do that. Now that I've got the reflexive property taken care of, I'm now going to handle the angle in between. So I want to prove that angle BAD and angle CAD, BAD and CAD, are equal to each other. I know that they're made up of 1 and 3 and 2 and 4, which I know that their respective parts are equal. So I'm going to start setting up some angle addition here to prove that they are. So angle BAD is 1 and 3.